Have you ever just scrolled through your phone and wondered how it can instantly find every single picture of your cat? I mean, it feels like magic, right? Well, it's not. It's the power of neural networks. And in this explainer, we're going to pull back the curtain and show you exactly how computers learn to see. So we're going to build this whole thing from the ground up. And we're going to do it by focusing on this one deceptively simple question. How in the world can you teach a pile of code to look at a picture and know, yep, that's a cat?
All right, to answer that, we have to start small, like really small. We're going to start with the single most basic building block of an artificial brain, one simple little decision maker.
Now, at its absolute core, this little unit works on a principle you might have even seen in a stats class. It's all about making a simple yes or no prediction based on some evidence. We're just taking that basic idea and using it as our first step toward building an artificial brain. We call this simple unit a neuron, and of course, it's not a real biological brain cell. Not at all. Think of it as just a tiny bit of math that does three things. It looks at data, it decides what parts of that data are important, and then it makes one final call. So how does our one little neuron actually see a cat? Well, first, the image gets totally flattened into just a long list of numbers, one for each pixel. Then, and this is the key part, the neuron gives each of those pixel values an importance score, something we call a weight. So a pixel that's part of a whisker might get a really high score, while a boring background pixel gets a low one. Finally, it just adds all that up to spit out a single number, a probability, like, I'm about 85% sure this is a cat. Okay, that's great for just spotting cats. But let's be real, the world is a lot more complicated than that, right? What happens when we want our machine to recognize a bunch of different things at the same time? Yeah, our simple one neuron setup is kind of a one-trick pony. It can only say cat or not a cat. But what if the picture could be a cat or a lion or even an iguana? All of a sudden, that simple yes or no answer just isn't going to cut it. And the solution, you're going to love this, is beautifully simple. We just add more neurons. One becomes our cat specialist, another one becomes a lion expert, and a third one becomes our dedicated iguana spotter. Each neuron gets trained for its own specific job. It's that easy. Now, here's the really important part. At this stage, these neurons are completely independent. They don't talk to each other at all. The cat neuron makes its guess without any clue what the lion neuron is thinking. This makes them way easier to train, and it also means the network could, in theory, say, hey, I see a cat and a lion in this picture. But everything we've talked about so far is still pretty, well, shallow. To give our network some real brain power, we need to add depth. And we do this with something called hidden layers. This, my friends, is where the real magic happens. You see, recognizing a cat isn't about just one single pattern. It's about combining lots and lots of smaller patterns. You know, things like whiskers, pointy ears, a specific shape of an eye. To see those kinds of complex combinations, we need to stack layers of neurons on top of each other, right between the raw image and the final answer. And we call these middle layers hidden layers. You might be asking, why hidden? Well, it's pretty straightforward. They're hidden because they don't see the original photo and they don't make the final decision. They live entirely in the middle, just processing information and passing along more and more abstract ideas. This layering creates this incredible hierarchy of understanding. It's awesome. The very first layer, it's not looking for a cat at all. It's just looking for super simple things like basic edges and patches of color. But the next layer takes those edges and colors and learns to combine them into things like eyes, ears, and whiskers. It's just like building with Legos. Each layer assembles more complex stuff from the pieces the layer before it made, until bam, the final layer sees a complete cat face. And the relationship here is super direct. The more layers you add, the deeper your network gets. And as the source material puts it so well, this depth allows the neurons to understand increasingly complex information. Simple as that. Okay, so we have the structure, the blueprint. But how does this thing go from being a random mess of neurons to an expert cat spotter? Well, the answer is pretty much the same way we do, by learning from its mistakes. Remember those weights we talked about? Those little important scores each neuron uses? The entire training process is really just one giant, massive search for the perfect set of weights that consistently gives us the right answers. So, how does it find them? You can think about the whole thing like a game. For every single image it sees, the network makes a guess. Then we compare that guess to the right answer, which we already know because a human labeled the data. the difference between what it guessed and what it should have guessed, well, that's its error.
In the world of machine learning, we use something called a loss function to keep score of that error. Don't let the name scare you, it's just a fancy way of putting a number on exactly how wrong the network was. A huge number means a huge mistake. A tiny number means it's getting really close. The whole goal of training is just to get that loss score as low as you possibly can.
This all happens in a constant feedback loop. It's a really simple process. 1, the network makes a guess. 2, it calculates its error score. 3, it then nudges all of its millions of weights, just a tiny, tiny bit, in a direction that would have made that error smaller. And 4, it does it again, and again, and again, literally millions of times. And when you boil it all down, that's really all training is. It's just this epic, high-speed game of hot and cold, where the network keeps nudging itself closer and closer to the right answer, getting just a little bit less wrong with every single picture it sees. And there you have it. That's the core idea. We started with one tiny decision maker, we scaled it up, we gave it depth with hidden layers, and then we let it learn from its own mistakes. With just those pieces, we've built the fundamental intuition behind all of modern computer vision. But this leaves us with one last really fascinating question to chew on. After all that training, after seeing millions of cat photos, does the network truly understand the concept of a cat? Or has it just gotten insanely good at recognizing a very, very complex statistical pattern? It's definitely something to think about. Thanks for joining this explainer.